Hello guys, you're welcome once again to Nisike Academia, and in this video I'm going to be exposing to you a very shortcut and very short method on how to, of course, derive the Henderson-Hasselbalch equation. And Henderson-Hasselbalch equation is a very crucial aspect of biochemistry that cannot be ignored. In fact, you cannot study acids and bases, acid-base theory, acid-base balance without studying Henderson-Hasselbalch equation. And the Henderson-Hasselbalch equation is the equation that shows the acid dissociation constant and of course the pH of the potential of the acid dissociation constant in buffer solutions. All right, so a buffer solution is a solution that shows resistance to changes in pH whenever small amounts of acids and bases are added to it. That's a buffer solution. All right, so buffer systems are very, very important in studying the nature of acids and bases, and it's important that you understand how to derive the Henderson-Hasselbalch equation. And of course, the Henderson-Hasselbalch equation came to life, was discovered, was postulated, was brought into existence by two scientists who worked independently. These two scientists were the Joseph Henderson and Carl Hasselbalch. All right, and they worked in two different periods, 1908 and 1928, to, of course, invent or bring about this equation. All right, and the Henderson-Hasselbalch equation is expressed as pH equal to pKa plus log concentration of the conjugate base divided by the concentration of the concentration of the acid. All right, so this is the acid, this is the conjugate base, and the conjugate base is the salt. All right, and this is of course concentration of the acid. Please take note of that. Now, in a reaction that has to do with the dissociation of an acid, remember that what is an acid? An acid is any substance that produces hydrogen ion as the only positively charged particle in an aqueous solution, while a base is a substance that produces hydroxyl ion as the only negatively charged particle in an aqueous solution. So basically, when we talk about buffer solutions, generally buffer solutions are of two types. We have the acid buffer and we have the base buffer. Now, the Henderson-Hasselbalch equation focuses primarily on the acid dissociation constant of the acid buffer. All right, so how do we simply and easily derive this Henderson-Hasselbalch equation? Now come with me. All right, so if you've not subscribed to this channel, do well to hit the subscribe button. If you like this video, hit the like button, and of course share as well, so other persons who are in the field of biochemistry can actually, of course, have a very good knowledge of this. Now come with me. All right, so basically, to get this equation, we start by expressing the dissociation of an acid. Now, when an acid dissociates, what is formed? Dissociates in water. Ionic dissociation by what? Complete solubility or complete dissolution or dissolving in water. We have H plus A minus. All right, this is what is formed. H plus A minus. Remember, both of them are in aqueous solution. So basically, you now have to write the dissociation constant. Ka means acid dissociation constant. You now have to write the dissociation constant of this reaction. And if you remember very well, in chemical equilibrium and in chemical reactions, when you want to write a dissociation constant or a constant for maybe equilibrium of a reaction based on the rate law, it's supposed to be a ratio of the concentration of the products divided by that of the reactant. All right, so basically these are the products, this is the reactant. So we take the concentrations. Anything in square bracket means concentration. We take the concentration of H plus multiplied by the concentration of A minus. Now please note, this is hydrogen ion that shows that it's an acid. Remember, an acid is a substance that produces hydrogen ion. A minus is called the conjugate base. A minus is called the conjugate base. So the conjugate base is the substance or ionic substance that is formed in the ionic dissociation of an acid, while conjugate acid is formed in the ionic dissociation of a base. So a base buffer has a conjugate acid and a base. I want you to know that anything conjugate, both acid and base, they are salts. A conjugate acid will be at the top while the base will be below. But now for acid, it's a conjugate base that will be at the top while the acid will be below. Please take note of that. Alright, so now this is the reaction. Like I said, you take the concentration of the products and divide it by the concentration of the reactants, which is of course HA, which is the acid. Then after this, what you have to do, cross multiply. While you cross multiplying, the next thing is to make the hydrogen ion concentration subject to the formula. So cross multiply. So your Ka will now be multiplied by your acid to give you, of course, your H plus concentration times your conjugate base concentration. Alright? So now after doing this, divide both sides to make H plus subject to the formula. Divide both sides by A minus. Divide both sides by A minus. So if this cancels this, now we'll be left with our H plus now. Our H plus will now be equal to Ka times Ha, all divided by concentration of your A minus. This is what you now have. Alright? This is what you now have. Because this cancels this now, so hydrogen ion concentration will now be this guy. Okay? So now after this, the next thing is to take the log of both sides. So take log of both sides. Take the log of both sides. But now what you need to express is this. Now if you're taking the log of both sides, you need to first of all express this guy as Ka, okay, then times Ha all over what? A minus. Now what you have to do, separate Ka, because of course this is Ka over 1, then take the ratio of the concentrations. It's more like you putting like terms together. So take the ratio of the concentrations and bring out Ka. It's still the same thing. It's still Ka times this all over this. So now you take the log of both sides. So this will now be this will now be log first. Log H plus. Log H plus will now be equals to log of Ka. Log Ka, okay, then times log Ha all over A minus. So this is what you will now have. Remember, they are just multiplying each other. This time is this. Alright? This time is this. You're taking the log of both sides. So you should know that it's still the products. Alright? Then after this now, what the next thing you do is to multiply through by minus 1. So when you multiply through by minus 1, it means you introduce minus here. So now this will be minus log of H plus will now be equals to minus log Ka, then minus log Ha all over A minus. Alright? Are you seeing what I did? I multiplied through by minus 1. I introduced minus here, introduce minus here, introduce minus here. Okay? So now I want you to note, if you could remember, when it comes to elementary knowledge of acids and bases, minus log H plus is known as pH. Alright? Minus log Ka is known as pKa. Okay? Don't forget this. Minus log H plus is pH. Minus log Ka is pKa. Alright? So if we want to now substitute these guys into here. So minus log H plus is pH, right? So this will now be pH will now be equals to pKa minus log Ha, concentration of Ha divided by concentration of A minus. Okay? Concentration of A minus. This is what we now have. Alright? But now we are not done. I want to let you know this. In this reaction, if you look at this reaction, you realize that basically from constants, when you want to express concentrations, the products are supposed to be at the top like this. Products are supposed to be at the top, while reactants are supposed to be below. So basically, you have to now rearrange this guy, this expression, to ensure that your A minus, which is your conjugate base, comes up, because A minus is a product. Ha is a what? Reactant. So you have to take A minus up, bring Ha down. So now, how do you achieve that? All right, how do you achieve that? Now, so what you have to do is to rearrange. Okay, I have already cleaned the expression, but you remember what we wrote initially. Now I said was pH equals to pKa plus log A minus. Let me just rewrite it. pH equals to pKa plus log of this. So now rearrange. We are already getting to the last point of this. Okay, we are getting to the point where we achieve this. So now rearrange it. So it means that rearranging pH now will be equals to pKa. Now, when you want to take A minus to the top and bring HA down, this sign will change to plus. So this will be plus log of your conjugate base divided by concentration of your acid, HA. This is what you now have. This is what you now have. Alright? So this is the Henderson-Hasselbalch equation. This is the Henderson-Hasselbalch. If you look at it now, it's exactly the same thing with what I stated earlier. So it's very simple. The first thing you have to state the equation. After stating the equation, you write the acid dissociation constant expression. After that, you cross multiply to make H plus O into a formula. Then of course, after that, you take the log of both sides, multiply through by -1, and of course write your expression. You have to take note that minus log H plus is pH, minus log Ka is pKa. Alright, so take note of that. Alright, so that is that. The application, why is Henderson-Hasselbalch equation important? It's relevant in buffer systems. It helps in understanding buffer systems better, just like we've talked about acid buffer here. It also helps in calculating and maintaining blood pH. The pH of blood is in between 7.25 and 7.5. It helps you to actually understand how to maintain blood pH. It helps you to calculate blood pH. It's also relevant in drug absorption. It's important in also evaluating agonists and antagonists in pharmaceutical industries and all of that. It helps to study different substances and how they relate to each other as acids and bases. So Henderson-Hasselbalch equation is very, very important, very, very relevant. So this is a simple technique to derive the Henderson-Hasselbalch equation. Like I said, if you have any question whatsoever, write a question in the comment box below. If you have, of course, very good interest in this video, don't watch it alone, also share it. All right, so thank you and see you in the next video.